Hey everyone, welcome back to BigBrains tip. We are moving into a new DSA pattern today, monotonic stacks. We are solving next greater element 2, where the interesting part is that the array is circular. For every element, we need to find the first greater element to its right. But there is one important difference here, the array is circular. So after reaching the last element, we go back to the beginning. So the answer for 1, 2 and 1 is 2 minus 1 and 2. The straightforward solution is to start from every element and keep searching to the right until we find something greater. But in the worst case, we may scan almost the entire array for every element, and that gives us O of n square. We can do this in O of n using a monotonic stack. Think of the stack as elements that are still waiting for their next greater element. We keep them in decreasing order. If a new number is bigger than the element at the top, we finally know the answer for that element. We pop it from the stack. Let's walk through the example. We start with 1. There is nothing before it that can help us yet. So we put it into the stack. It's now waiting for a greater element. Now we see 2. The top of the stack is 1. Since 2 is greater than 1, we have found the next greater element for 1. So we put 2 into the answer for that position and remove 1 from the stack. Then we push 2 because 2 is now waiting for something greater. Now we reach the final one. It's not greater than 2, so it can't solve anything yet. We push it onto the stack. But remember, the array is circular. So after reaching the end, we need to look at the beginning again. That means the first one can potentially find a greater element after wrapping around. Now the current one, it's still not greater than the top. So now we see 2 again. It's greater than the waiting one. So we can resolve that one as well. The remaining 2 has no greater element anywhere in the circular array, so its answer stays -1. We don't actually need to create a second array. We can simply iterate through the array twice. The index is calculated using modulo. So after the last index, we come back to the index 0. So index 3 becomes 0 and index 4 becomes 1 and so on. And that's how we simulate the circular array. Now the algorithm becomes pretty straightforward. We loop through the array twice. We get the real index using modulo. While the current element is greater than the element waiting at the top of the stack, we have found its answer and pop it. During the first pass, we add indices onto the stack. The second pass is only there to give those remaining elements a chance to find a greater element through the circular wraparound. Now we can start solving the problem. Initially, I'm just having a variable called n and it equals the len of nums. And then I'm having a variable called result and it holds all -1s and it is of say n times. And I'm having a stack which is empty at the beginning. So now I'm having a simple for loop for I in range of, I'm having like 2 times n since it is a circular loop, and so current equals nums of I modulus n, and stack and while the stack is not empty and current is greater than nums of stack -1. If that is the case, if current is greater than the top element, like the result of stack, say stack dot pop off. So for that specific index position in result array, I have to assign with current, and then if I is less than n, I just have to append I to the stack, and now I have to return the result. This must work. Yes, it did. Perfect. The key idea is the stack stores elements that are still waiting for something greater. When a bigger number arrives, we can finally give those elements their answer. And because the array is circular, we simply make two passes. And that's chip 13. Don't memorize DSA, recognize it.